Hi friends, welcome to G's sRRBHub. Today we are going to deal with a portion from electronic measurements. This will be useful for RRB technician, RRB JE as well as Kerala PSC PWD engineer exam. So let us get to our classes. Our topic is LVDT. In the previous class we have discussed what is meant by transducer and its different types. I have left this topic LVDT. LVDT stands for linear variable differential transformer or linear variable differential displacement transformer. It has obtained the name differential because the output is differential. It is called displacement transformer because it is used for measuring linear displacement. This kind of transducer measures linear displacement which is converted to electrical form. And it is called transformer because it involves secondary and primary windings and its working principle is similar to transformer, that is mutual induction. Now let us see the construction and working of LVDT. This is the construction of LVDT. It involves three solenoidal windings around a cylindrical tube, and a soft iron core moves through this tube, which is connected to the object whose displacement has to be measured. As the current flows through the primary winding, an EMF is induced in the secondary winding corresponding to the flux linkage with the soft iron core that moves within the tube. This is the construction of LVDT. Now we can see and explain the working with the help of the wiring diagram. This is the primary winding through which current flows. This is the soft iron core which is attached to the object whose displacement has to be measured. There are two secondary windings, S1 and S2. ES1 is the EMF induced in the first secondary winding and ES2 is the EMF induced in the S2 winding. And the difference between ES1 and ES2 gives the output which corresponds to the linear displacement of the object connected to the soft iron core. Three cases arises due to the position of the soft iron core. First, let us see the initial condition, that is when the soft iron core is at null position, that is there is no displacement. In that case, soft iron core is towards the center of the tube and the flux linking with both the two will be equal. In that case, ES1 will be equal to ES2. Then ES1 minus ES2 is 0. That is, the linear displacement is 0. Now when the soft iron core is moved out, then its flux linkage with S1 is more than S2. So similar with the EMF induced due to the current flow in the primary, ES1 will be more than ES2 and the difference will be positive. Now when the soft iron core is moved towards S2, that is moved to into the tube. In that case, the flux linkage with the secondary winding S2 will be more and ES2 will be more and the difference will be negative. This is how LVDT works. I think you are clear with the working of LVDT and its construction. In the next slides, I have explained how LVDT is constructed and also the three cases which I have discussed now. You can pause the video and go through this. With this, we have come to the end of the topic transducers. In the next class, we will deal with some previous questions from the topic transducers. If you're having any doubt, you can comment below. Thank you.